degree in engineering and management. The SDM program also offers a one-year certificate in system and product development. We are pleased to have Mr. Saurabh Dota and Mr. Todd Beardsley present today on balancing usability and cybersecurity in IoT devices. Saurabh Dota directs the experience design team at Rapid7. He has worked in design and usability domains across physical and virtual products for more than 15 years. He is alumnus of System Design and Management program and holds a master's degree in engineering and management from MIT. Saurabh also has a master's of science in architecture and design from Mississippi State University and a bachelor of architecture from Birla Institute of Technology in Mesra, India. Todd Beardsley is a director of research at Rapid7. He has more than 20 years of hands-on security experience, stretching from in-band telephony switching to modern IoT implementations. He directs the myriad security research programs and initiatives at Rapid7. Todd holds a bachelor's degree in information technology management from Western Governors University. Saurabh and Todd will present for approximately 45 minutes, and then we will open up the webinar for questions. Please use the chat feature on the webinar to ask questions, and we will respond to as many as possible. Please join me in welcoming Saurabh Dota and Todd Beardsley for their talk today.
Thank you, Eric. So, hi guys, I'm Saurabh Dutta, and I'm going to, I just want to start with a quick background, and I think Eric already gave a good introduction. Just wanted to reiterate, mostly my experience has been in the design world and start to think about design thinking and system design, both in the virtual space and in the physical world, in architecture of actual buildings. And have been working with in cybersecurity space for last decade, and and I will be sharing my thoughts today with Todd, who is a colleague with me at Rapid7. And Todd, if you want to talk a little bit about yourself before we get going.
Sure thing. Yeah, I'm an IT guy from way back. I worked at a tiny little ISP in Pittsburgh, Pennsylvania. Was I think my first real job, and then from there I've worked kind of all over the place at large and small enterprises. And as things went, kind of slid my way into security there. And so I've spent the last 14 years or so doing security engineering, doing a lot of security research. Exploit development, vulnerability research, development, things like that. So I am super excited to be talking to all you MITers.
Great. So we'll move into the agenda for today. What we'll do today, what we want to present is the balancing the act of usability and security, and you can also argue like innovation and security, and we'll get into that in a bit. But our primary focus today will be to get to that analysis, like how do you analyze like how much security is good, or like how do you balance it, right? So we, if you see the last 2 points in our agenda, probably that's where we will focus most. But then to set this up, we will go through what is the overall markets of IoT, where it is going, why this topic is important, why the usability security paradox is important, and we need to think about it. What do we do about it? So we will talk about a IoT security framework, which we think can help with the said paradox. Then we'll talk about who are the actual stakeholder holders for this, and we will put some system design thinking into the stakeholder analysis and see who are we really targeting with this framework. And then we will talk about like what are the attributes we factored in when we created this framework from a usability standpoint, and same thing, what are the attributes we focused on the security from a security standpoint, and then jump into a couple of practical examples and applications, so we can see if this framework can work or how it can be helpful. So that's our agenda. So without any further delay, we'll move into our first topic where we'll talk about the market. So these are just some high level numbers we wanted to talk about. Gartner, which is a independent research organization, it predicts by 2020 there will be like 95% of all electronics and new products will have some component of IoT. Somehow it will be connected to internet. Um, so and same thing, Bain, which is a big investment group, it predicts the consumer applications will generate $150 billion by 2020, and then the wearable market is expanding, right? And I'm sure everybody listening in today have some kind of wearable, or you have relatives or friends who have these, and it includes from watches to medical devices to and then moving into other technologies like the smart home technologies are at the forefront. Everybody has some kind of um, smart home technology that in their home nowadays, starting from a thermostat to security system to cameras, um, and whatnot. So that's the consumer side. But if you look into the enterprise side, it's growing even bigger. Like again, Gartner predicts 65% of enterprise will adopt IoT products, right? And what are these enterprise things like discrete manufacturing, transportation, logistics, utilities? These all are huge, and they will be leading the IoT enterprise spending. And then one other thing very interesting is that like why people are moving to IoT, like how this Internet of Things, why is internet connected infrastructure is now a in thing, and like why they are investing on it. It seems like 70% of it is to, like, there was a survey done by one of these independent research group, and it suggested that 70% of them are using it to improve the customer experience, while 56% of them are uh, are actually utilizing it to increase safety, and then there are other things which are like increasing automation, increasing of efficiency and optimization. They all are around the same range. But these are all highly rated reasons why enterprises moving to Internet of Things.
Yeah, and if I could just jump in there, Saurabh, like, I mean, this just bears underlining over and over again. Like, if it is a device today that uses electricity, it will be on the internet. I don't think there's any way around that. It's just the internet is just way too useful for things like data aggregation, data analysis, and doing complicated like voice recognition and facial recognition and aggregating all your data from all your sensors. So like, I mean, a hammer probably wouldn't hit the internet in the near future, but pretty much like you say, like a thermostat, a watch, anything, like anything that has electricity will act as a sensor and will talk on the internet. And it's not just like it'll talk on a network; it will talk on the internet directly. Implementing a TCP/IP stack is pretty straightforward business today. But the I in TCP/IP stands for internet, and I'm stealing that from a tweet I got the other day from Decryptsy, where he mentions that all networks are hostile. The I stands for internet, so it is naive to think that your devices will not be participating on a hostile network soon.
True.
Yep.
As the Gartner says, 95% of everything. So you just hit it right, Todd. Uh, right. Let's move on to like why we are talking. Why is this topic important? What we are talking today. So the Internet of Things, it has like brought people a wealth of benefits, right? Like from quick Uber rides to remotely control the heat levels in your home. But are these devices compromising our privacy or even our safety? Like, is there have you guys experienced this? Like, Todd just mentioned about data, right? And we just saw there, like, we see all these data breaches, or even like companies who basically have these data can sell it, right, or can give it to third party, and you don't know what is happening there with you. So there's always these, if I enable and if I want to get this benefit out of this product or this services, what am I losing? um, and we want to do a deeper analysis on that today, and see how vendors can help, or vendor how we should think about this problem. And I'll just take three examples today to quickly highlight this. One of the examples is captcha. You may have seen this in many website. um, are you a human? Like, it does a quick check, and captcha is in forefront of many website to just make sure that you are a real person. And what happens, there is a company, there is this company which surveyed Distill Network. It surveyed a group of people, and if they found that every time there is a captcha in a website, 27%, it's 27% less likely that the user will move forward. So which means that, since there is this one more step, sometimes people just starts dropping down. So the traffic in that website goes down, for just one reason. So you see, like, there is this, you added a little bit of more security, but then it was not convenient enough for few, and they dropped off. The other good example is two-factor authentication. I'm sure a lot of people have been using it now. Now it's getting more mainstream. Like, we have two-factor authentication. We have like all sort of two-factor authentication companies, and especially in the work area, it's kind of a standard now if you are working for a company. And and there was another experiment where 61 users were involved, and they were given these different types of exercises, and surely they found, like, every time there is two-factor authentication, the usability gets degraded over the single factor authentication. And then, a bigger example is, there are these certain types of insulin pumps where the uh, this is used by the diabetic patients to, if you know, it's artificial pancreas, right? So it maintains the blood glucose level to keep the patient healthy. And what happens is, in some of uh, these systems, they have the Bluetooth technology by default switched on, so that, for example, for some good usability reason, like, for example, if a patient just walks into a clinic, the doctor already can access all the information, all the vital information, and by the time the patient meets the doctor already knows all the information. So, oh, I checked everything. It seems like this is what's going on with you. These are the healthy part. These are the things you need to take care about. So you see, it's so frictionless. But to enable that innovation, to enable that usability, um, the Bluetooth technology is enabled always on, which actually opens a huge loophole where, a hacker can remotely hack into these uh, these artificial pancreas, and can create can harm the person, can create havoc. They can, if they can hack into the system, you know and mess up with the blood glucose level, it's pretty risky. The patient may die. So there are these huge risks to it. Um, so that's what the challenge is. Todd, I don't know if do you want to add anything here?
No, I think you covered. I mean, we do live in this world where we kind of just by default think that usability and security are incompatible with each other. They're two ends of a spectrum. And I do think that that the research here, Saurabh, shows that doesn't necessarily have to be that way. I kind of feel like if a device has a security feature, like a CAPTCHA or like some kind of authentication that degrades the usability, like that itself is a security problem, right? Because like if I make something that's super secure that nobody uses, then obviously, you know, it's not just a usability failure. It is a design failure of the security mechanism. You know what I mean? So like, yeah, like if I'm forcing you to have to like hand type in a 64 character password to, you know, do a thing, yeah, this is a failure of security. This is not necessarily a data point of, well, security and usability are just incompatible with each other. You just gotta try harder with security.
Yeah, that's a great segue to and that's why we are talking about the security framework. I to say so. As Todd mentioned, like they are not necessarily, usability and security is not necessarily antagonistic. You know, they just feel like it at the first glance, but as you dig deeper, it's probably a different. It's the indication that, you know, we do not have a good practice or pattern or principle in place. You know, if we can put a good practice pattern principle in place, then you know, we think that the security and usability or innovation can go hand in hand in a more synergistic way.
Yep.
So
I mean, my go-to example for that is SSH as a protocol. So we've got a bunch of, you know, nerds on this, all right? So everybody knows what SSH is. It's you use it to, like, you know, get a console on some remote machine, and SSH replaced Telnet by and large. Like, and there are some parts of the world where this is not quite true. We'll get into that someday in the future. But SSH has replaced Telnet largely in professional organizations as a way to do this remote console. Now, it is incidentally more secure, like way more secure. It has all kinds of features for PKI and mutual authentication and the transport encryption and all this jazz. But the reasons why system administrators picked it up is because it is just so much better than Telnet. You know, you have compression on the line. You have long-lived sessions. You can do things like passwordless authentication. You can, you know, SCP comes for free, so I don't have to do FTP anymore. So like SSH is a story of, we got a better security solution to a problem by dint of it just being better usable, more usable, and a better user.
yep. And as Todd mentioned, these are some other examples from both worlds, from usability world. If you see, like, copy and paste, drag and drop, these are just good practices, right? And the same thing from the security pattern, like the SSL, the email-based identification and authentication for resetting password. These are just good principles. And if we can have a similar principle for IoT devices, I think you know, we can get to that synergistic level. And that's what this whole topic is, and this whole framework we are talking about. So what we wanted to do is, like, what we did was we took the systems thinking approach to do a stakeholder analysis. Like, okay, who are we really targeting this IoT framework for? So we did a bunch of study and research, and you know, if in this diagram, I'll try to quickly explain this. It may be a little dense, but I'll try to explain it. So think about this as the focal organization, right? This is what we are talking about. I mean, we thought about, okay, who all are people who may get affected. So, you know, definitely the IoT device makers, we want them to produce more safer products, right? um, and you know, and then of course the end consumers, right? But then there are other people who gets affected also, like the investors who are spending money on this IoT device maker, because, you know, if something fails or a breach happens, there is a huge cost to it. And Todd, do you have any numbers on top of your mind on like cost of breaches?
Billions. You know, I mean, it's tons. You know, like more money than appears to exist on Earth is the cost of some of these breaches, because you have not only like the direct cost, but you have indirect costs, right? You have cost, you have a reputational cost. You know, you have fatigue. Like we've been through many breaches, and at this point, like there are a lot of people out there who says, well, all my stuff is already owned, so I don't care anymore. You know, that itself is a cost. So like there's a lot at stake.
Yep. Cool. And then from if you see like even the insurance companies, right? So a lot of these, say if if a medical device is hacked, right? Like there is and if a patient is harmed, like think about these, like there is different levels of insurance and insurance companies which can get affected with these kind of breaches or these kind of safety issues. Then on top of it, there are regulatory bodies, right? So you have to if you are working on a sensitive um, area, like in the transport industry, or a automated car, anything which can really harm people or environment, or it needs to go through the regulatory bodies, and which is part of which regulatory bodies are part of government. And also the law enforcement, if really something if an incident happens, and who is to blame. And then within this system boundary, we also, if you think about it, the cyber criminal, like we kept it a little away from system boundary, but in reality, this is also, when we are thinking, this is also part of the stakeholder, or they are at least a parallel part of our stakeholder analysis, where we see like ultimately these are the culprits for whom we are like from whom we are trying to protect these devices, right? So security vendors play major role. Rapid7, like where we work, is a security vendor, and like they have, they work with these so many customers and just consulting services. And also companies like this have a lot of knowledge around it, and I see like that knowledge can be used for this IoT security framework. So you see like these are different relations, and there are some must have relations and should have relations and might have relations based on Kano analysis. And so that's kind of high level. As I mentioned, like we are trying to uh, go closer to the two last topics where we want to focus more. But if you have any questions, we will be happy to take those at the end. But I'll move on. So what gave that stakeholder analysis gave us that, okay, the framework we are making is for somebody like a product manager or a developer at a IoT device maker company. The goal for them is to ship new features and products successfully, but the problem is to understand the security implications to feature request before implementation, right? And the solution we are proposing is a IoT framework makes this persona, whoever is in this role, aware of the potential security issues and better protect the company from releasing products that introduces unanticipated risks to their customers. And then how we'll talk about it during the application session. All right. Uh, with that, we'll quickly talk about the usability functionality attributes. So, you know, at a high level, any product has two types of requirements. The functional requirements, which are very specific to that system. So, again, since I'm picking the example of artificial pancreas, the functionally their main job is to maintain the blood glucose level, uh, make sure they have a good battery life. These are kind of functional requirements, while non-functional requirements specify how the system works or how the system should behave. So usability is generally the is on the non-functional requirements. So make sure that it's usable, it's easy to operate, and all those sort of things. So there are like, as I mentioned, like our focus is on the security part. Usability analysis and usability attributes are have been done, have it has there has been a lot of research. There are like some big companies and big authors who and they have established attributes, like what are the primary attributes of usability. So we didn't do a deep research on that. Instead, we borrowed, right? Because there had been already usability world has been very uh, it's a old established paradigm which works. So instead of respinning wheels, we just borrowed them. And this is these we use these 10 attributes for our framework, and these are based on something called QAM, quality in use integrated measurement, which is a common standard. And the attributes of usability we selected are efficiency, effectiveness, productivity, satisfaction, learnability, safety, trustfulness, accessibility, universality, and usefulness. Again, we can take questions if you have questions on any of them, but we'll move into our primary focus on the security attributes. So Todd, you want to take this and give us a quick round?
Sure thing. So when we talk about security, namely security failures, we tend to kind of focus on three main areas of security failure. The first one is a failure in confidentiality. And essentially what this means is that if I have a security bug and and it comes to pass that it gets exploited, I've lost confidentiality of some kind of private data. I cannot assert that the data is is private between whomever are the stakeholders of that data. We also have a problem of integrity that is, so like if you think of confidentiality loss as like a data breach, I got a bunch of usernames and passwords for some site. An integrity breach means that I have more control over the system than what was intended by the inventor or by the deployer of that system. So that may mean I have persistent access to your store of usernames and passwords. Whereas then with availability, this is almost always described as a denial of service. With IoT in particular, an availability failure means that this device isn't working anymore. So maybe I delete all your usernames and passwords. And now no one can use it. So like the kind of go-to example we use in IoT is that in a smart home, if I can DOS your house, like this makes life bad for you. Like you cannot enter it anymore, or the heat doesn't work anymore, or something along those lines. So we know a bunch of security people, some of them very smart, and a lot of them that do work in IoT. And so we put together a survey, essentially trying to figure out, what can we distill security attributes in a similar way to the usability attributes. And I really wanted to come up with 10 security attributes, but I don't think we did it. I think we landed on 15 because security is hard. So I'm gonna roll through these pretty quick. We've got some time. So let's just jump into it. The first thing that is very defining, very specific to IoT is physical security. So if we're designing a feature, some new feature for some IoT widget, we need to make sure that the people that use the thing and the people that are around the thing are safe from harm. Also environmental factors. So like, for example, if I have a IoT gas pump, if I can, if a problem in that can cause like a pressure issue and now my gas pumps are all exploding, I'm hurting not only the gas pump, but I'm hurting the people around the gas pump. So that would be a big bummer. Next up, okay, so IoT also tends to have a remote control attribute to it. In traditional computing, we have a keyboard, we have a mouse, we have a monitor. We're touching it, where we have instant response, we can read things. You often don't get this in IoT, and so this remote control area is how does this IoT device interact with the world, either with a user or another device, and often that goes over some kind of radio. Be it Wi-Fi or Bluetooth or near field communication, something along those lines. And so any kind of feature around that needs to take into account. It's like, well, RF, I might intend this device to only talk to another sensor that's 3 feet away, but can an attacker, trick it into talking to something that's 300 feet away, or something like that. In IoT, ongoing maintenance tends to be kind of the bugbear of IoT. It's oftentimes very difficult to patch, devices that are already deployed in the field, which is just crazy to me, because the thing that makes IoT so useful is the fact that it can talk to the internet. So if it can talk to the internet, we should probably build in a patch pipeline there. So like when problems are found, they are able to be fixed. And so this is an area that the IoT industry is getting better at incrementally, but firmware updates are always a hassle.
Yep. I think we have seen some Tesla upgrades over the year on that note.
Tesla can apparently upgrade without the presence of air, so that's so good for them. Like they're absolutely a market leader in this over-the-air updates. They were I believe the first auto manufacturer that just had them on and on by default, so like the users didn't even notice. Authentication is a big deal in IoT. Oftentimes with these devices, the mere fact that you're present is authentication enough. I just got in a fight this morning with my 10-year-old over the Amazon Echo because turns out Alexa doesn't care who says stop and start. This is I feel like a fairly major problem with Echo. I can't lock out my jerky kids. So this is an authentication issue here.
Hey, we have that. I think Amazon Fire TV does allow that though. Like you can put
sweet.
You can put a password on that.
Okay.
Yep.
Yeah. Yep. And which goes to authorization. Authentication and authorization are very, they're kissing cousins, but they are different things. Like not only do I have to prove who I am, but also that I should have the kinds of permissions that I'm requesting. So like if I have a device that has multiple tiers of data, for example, like I might not want to let my sensor disclose information about other users, for example. So like let's say a artificial pancreas or a glucose reader. Like just because I'm authenticated and authorized to mine doesn't mean that I should be authenticated and authorized to yours, even if we're in the same waiting room. And input validation is a fairly classic computer security issue. So basically, there is a commandment in secure design that says, "Thou shalt not trust user-supplied input." If you're expecting a username and I give you 4 gigs of A's, you should be able to roll with that and tell me that I'm crazy and no username has 4 gigs of A's. Sanitization, again, is similar to the input validation, but it tends to be a step afterwards. So like this is usually this is always the root cause of like something like a cross-site scripting vulnerability or SQL injection vulnerability in a web application. With IoT, IoT is a little bit different in that once you have input, it does get written somewhere and it does get sent, it gets recorded somewhere and gets read somewhere else. And so you tend to have to, in a secure design, you validate when you write it to disk, and then you revalidate when you read it back off a disk, because you might not know like what happened in between. And so the validation and sanitization kind of go hand in hand with that. Transport security is often overlooked when we're talking about remote control, talking on radio frequencies. A lot of proprietary protocols especially don't support transport security at all. And so a failure here means that a third party can see the data, can possibly modify the data in transit, and that's kind of ruins your sensor, right? Like if I can't trust the sensor, then it's kind of game over. Auto manufacturers use and almost all transport actually uses a protocol called CAN bus. CAN bus tends to not be encrypted, tends to kind of throw transport security out the window, but it's okay because oftentimes cars will not trust every sensor fully. So like if you have, if your car notices that, one of one of 4 of your wheels is reporting that it's breaking, but you're not really braking because someone has like hacked your braking system, which would be, you know, disaster. You know, it will assume that like, oh, well, this is a failed sensor. I'm not actually braking right now. One thing that is often overlooked is this, you know, the problems that we run into with breaches. You know, when we have like giant troves of sensitive data leaked, is one of the best solutions to that is don't store the sensitive data. Like if there's a way to, you know, achieve whatever function you're trying to do without, you know, a long or even medium term storage of data, like, you know, try to like favor that solution over the solution that means that you store the data forever. And for sensitive data in this context, we also talk about passwords. For many IoT devices, you know, you might have a PIN or a password, or, you know, the Fire TV, you might have a spoken password or something like that. But people, you know, despite all the counter programming we try to do on humans, people still tend to pick the same passwords over and over again. And so disclosing a password on a single device may not be that big of a deal for that device, but it could be very useful for like a future attack, you know, especially one that's targeted to the people that are using that device. I would say the more sophisticated IoT devices do leverage encrypted data storage, you know, but a lot of the cheaper and much more lightweight ones don't. And this is you know, again, this is a kind of a cost trade-off with security. A device like an iPhone or, you know, kind of any modern Android device has secure storage available, but we do see problems in mobile devices in particular, where an application just deigns not to use the secure storage. So this tends to be a design error. You know, these platforms are pretty good at making secure storage available to the developers, so please use them. Underpinning a lot of this is encryption, just kind of in general. But what this pillar of security is about is not only just have encryption, but have like good encryption. We get bit over and over again with the very old encryption standards like RC4 that tend to be used in conjunction with, like, say, a downgrade attack. If your device supports multiple encryption protocols, you know, you're the good user, you know, the happy path is going to choose the best. The attacker will always choose the worst if he has the choice, and so can leverage bugs in that. So it's not necessarily just like I said, it's not just have encryption, but like test and make sure that your encryption is up to date. And if it's not, hey, you know, you got to get back to your maintenance and your patch pipeline and all that. Logging is often absent on very small sensors. You know, they hear a thing and then they just repeat it, and they act as a repeater, which is a little bit of a bummer. It's nice to have logging available for the events that are not just security issues, but just kind of normal failures. I mean, logging is super useful for that kind of thing, and it's a feature that is often overlooked in, I'd say, in products that are earlier on in their life cycle. Typically, you see logging later on. You know, now it's also important that these logs themselves be stored securely. You know, logs can give away a lot of information to an attacker who can access the logs. The logs should be, you know, pretty resistant to tampering. So something like, you know, we have an excellent use case of logging, and that's called blockchains, where the log is immutable, and so that gives us a mechanism to, you know, kind of review the past and see what went wrong. Auditability kind of goes hand in hand. The logs are great, but they're useless if no one can get to them. If I am in the middle of a disaster and I have to get on a customer support line to get access to my logs, that's a little bit of a fail. I should be able to at least be able to audit my own device to see like what happened, what happened and what's likely to happen. And again, this is not just in the case of a security problem, but in just kind of a normal failure. This auditability on IoT tends to be pretty light because there's such a focus on just the usability of it, right? Like I do on the Amazon Echo, like I don't know how to review like, whoa, what are the last 10 songs played or something like that, right? And that may be important for something. Oh, do we have logging twice? Oh, well, cool. Let's look at that. All right. And transparency. I'm a big fan of transparency, and it's not just because I'm a big old hippie who loves the MIT license, but transparency, for all its faults, does give users more chances to have like a reasonably secure code. If an auditor can come in and review your code and see all your obvious, string copies and say don't do that, then that tends to be a win for the code base. It's not always practical to have 100% open source and open design. But when you tend to have something that's more transparent, it tends to be more, I will say it tends to be more secure. It's not a silver bullet for sure, but it's a lot easier to find bugs when not just the 4 or 5 people who wrote the code can actually look at the code.
Yep. Cool. Thanks, Todd. One thing I'll just say, like, as you guys can see, like there are a lot of these, right? Like there are a lot of them, and we do want to suggest that, okay, what's the most ideal way to go? And we know that, or it may or may not be always feasible to make sure that everything is 100% right on day one, but these are the general guidelines we would like uh, the vendors to follow. On that point, we want to kind of show you a couple of examples, couple of applications, like how this research or how this study can be applied. And I think we have like around three more minutes left to talk, so I think we can go through this. We'll just give example of two different applications. One which we are calling system security scale, and what it is um, we borrowed the name from a existing, in the usability and UX world. There is this something called system usability scale, which basically provides a quick and dirty, uh, it's a reliable tool to measure the usability. It consists of 10-item questionnaire and evaluates a wide variety of products and services, including hardware, software, all those. And it has been there for last 30 or 40 years, and it's done in a way that it's still very useful, and it's being used widely. Even like if you go to usability.gov, and the standard government's yeah, usability site, they do strictly follow the SUS scale. So we thought that why not use something similar in the security world, and we created this system security scale. It's similar. It has those 10 questions, and we have some recommendations, and we have some attributes around it. So I don't know, Todd, do you want to talk a little bit about this?
Sure, yeah. So, similar to the SUS, what we're trying to do with this system security scale is we're not trying to prevent people from writing bugs, right? Like bugs are going to happen. Like they're essentially inevitable in any kind of complicated software. But these are the kind of questions that are pretty quick to answer, that a project manager or product manager or developer could look at to just really get them thinking about it, right? So like, for example, like if we have a question of like, is it important? Like, let's say you're thinking of a feature. And let's say you're thinking of a feature that for your IoT device, it's an IoT door lock, let's say. And I want to be able to trigger my door lock with Bluetooth. So I can answer this question, right? Is it impossible for this feature to affect the health and safety of people or property? Well, the answer to that in this particular case is no. Someone can use a pretty decent high-powered Bluetooth device to lock, you inside while your house is on fire. This would be a case where this would be, this absolutely would affect the health and safety of the people or property. Or unlock it, when you have, burglars with guns outside or something like that, right? So it's
Yep.
not that you shouldn't have the feature, but just thinking about like, well, how could the feature be misused? We can talk about, and we
Yep.
are running a little bit low on time, but we can say things like, all of these questions kind of go to one or more of these security attributes. And so there are ways for us as security professionals to infect product developers with security memes of they should just be thinking of it, because I can't tell you how many times I've been on an assessment and I've been involved in assessments and vulnerability disclosures where the vendor never considered using local the local secure data storage that's already available on the device. So just getting these questions in their heads does a world of good, similar to how the SES is used.
Yep. And the idea is like, this is future work, but the idea is like, can we get to think about this way, like how do you optimize, usability, security, right? So can we get to a point where, think about it like with the SUS, security, the system usability scale and security usability scale, can we get to a point where we can create a scale which looks like the ubiquitous blood pressure rate, right? So 70/85. So how much secure and how much usable this particular product is, like how can it be helpful? Maybe you, if you are buying a medical device which is pretty critical for in terms of security, probably we want it to be at higher security rating than usability. I don't know, like there can be these kind of different, what we want to give is that a clear transparent way to measure and to improve on it. So this is some future work we thought that can be applied on this. The other one, which I will very quickly go through, is
Good luck.
yeah, I know. QFD is a very popular system thinking tool, which is used for prioritization, which is used for, if you are a product manager or if you are working on, okay, what is my MVP? What's my minimum viable product? Like, where should I optimize? If I have $100, where should I spend it to get the most ROI, right? So as Todd showed, like there were like 13, 14, 15 different security features, and maybe you may not have time or resource to optimize everything. So that's where you can basically use this study and then use the QFD, which is pretty popular tool in the system thinking world, and you can use it to prioritize. And I'll just show like how. So in this case, what we are doing is, if you see the roof here, these are all the security requirements which we just talked, right? Physical security, remote control, maintenance. I kind of grouped some of the similar ones, like the auditing, logging, and the data storage and encryption. But these are all the security requirements. And then these are the usability requirements. Now, the usability in this particular example, I'm using again the example of an artificial pancreas system. So the usability requirements and functionality requirement of an artificial pancreas system is that it should be able to operate. And this came through a research. What we did was let me show you in the appendix. What we did a deep research, talking to patients, doctors, caregivers, customer service, like what are the most important feature you want from your artificial pancreas system, right? And how they are connected with what kind of usability attributes they are aligned to. So we came up with these top 10. We did a stakeholder analysis for that artificial pancreas system and how the IoT security framework can work or help, and then got into this. We mapped the QFD by putting so if I reduce the noise, what you see is the security requirements and the usability requirements. And then we calculated it based on, um, there is, for example, like, let me just give you an example. Um, the there are these strong relationships, strong correlations, right? So for example, in this case, improving encryption and data storage will also improve sensitive data security. So they are kind of, that's why they are kind of strong correlation. Another example is improving security for remote control feature may make maintenance of a device by customer service more difficult due to accessibility, right? So there are these pros and cons. So we took those pros and cons into account. Then we also did the relationship, like how do we optimize, how do we make sure that they are getting the most functionality without reducing the security. So no strong negative relations, right? And we mapped all of that, and then we calculated, and it came out that in this particular example, if you can only do three things, you should focus on physical security, transport security, and remote control. So I just wanted to show you like how you can use this research into some of the other design thinking tools for prioritization of your product priorities. I think that's it for today. I think I'll open it up for questions at this point.
Cool. Thank you very much, Saurabh and Todd, for that excellent presentation. Reminder for our viewers, we do have this will be now our Q&A session. So if you have any questions you'd like to ask, please use the chat feature on the right side there, and we'll get through those as we can. That was really a great presentation, guys. I'm definitely more on the fence of with the security with IoT. I feel like can be a big help for a lot of the world nowadays, but not enough people, as well as companies, really think too much about the security behind it. I'm also kind of on the board of does everything really need to be connected to the internet? I'd be kind of curious what you guys think about that, because I don't really need my toaster to send a tweet out. Oh hey, Eric just made a Pop-Tart. Congratulations! Sure. Yay!
Yeah, and you can have, and I often hear this argument. It's like, well, should it really be on the internet? The kind of go-to example there are electronic voting machines. Should those be connected to the internet? Probably not. But just like the upside is just so overwhelming for the device manufacturers, the vendors, and the users. Like if I can vote over the internet, like, and not leave my house, I mean, that's a huge bonus. Like, I don't have to go stand in line, like, and look at my neighbors, like that sucks. I just think that it's virtually inevitable. I think if you look at any other industrial revolution that we've had as a civilization, like it's real hard to resist that progress, even if that progress does seem a little more sideways than forward.
It's funny you bring up the voting machines. I attended DEF CON last year, and they brought out a bunch of voting machines for people to kind of toy around with them. It was very fascinating to see how quickly people were able to kind of break into them, as well as on the back end, a lot of them were still running Windows XP, so exploits were very, very easily open.
Medical technology is often Windows XP technology, like almost always. XP was just like, it came at a certain point in software development and hardware integration that everyone picked it up. And so when you're talking about like hospital security and any kind of like large medical device, you're almost always talking about a Windows XP device.
That's a bit frightening.
Yeah. So good luck.
Yeah. All right, well, while we're waiting for our viewers as well, I'd just like to say on May 8th, we'll be having another webinar. That'll be by Jorge Moreno, as well as Donnie Halashitz, co-founders of Nodu, as well as SDM alumni. And their webinar will be Renewable Energy Integration Opportunities in Chile. So registration is currently up on the SDM website for that, if you'd be so inclined to check it out. Looks like I don't have any more questions through the chat over here. So if you guys have any final closing comments at all, or anything else you'd like to drop before we close up today?
Yeah, I mean, I think that at least the users of IoT, I do think are getting more and more sophisticated, and that by users I mean humans. you know, we see a lot in the news. Like, I don't think you can go 3 days in the news without hearing about some kind of breach or some kind of like security issue with computers or the internet or something like that. And so people are definitely more aware of it. I'm optimistic that users will demand it. That you know, if you can compete on security and you can have a more secure device, you know, that is in maybe all other ways identical to your competitor, and your more secure device that costs another $5, like, okay, so that costs another 5%, sorry, is would have a pretty good chance at winning out. So I'm optimistic, and also we have to. You know, we don't get a lot of choice, because today we're not just securing the IoT devices themselves, but we're securing everything else from the IoT devices. When we have, you know, thousands to millions of these things kind of hanging out on the internet with default usernames and passwords that no one knows how to change, you know, bad things happen, and those bad things end up being things like, you know, massive distributed denial of service attacks against, you know, Twitter, which people seem to like. So
Yeah, I'll just add one last thing. Like, we should not just blame, uh, like, again, the same thing. Like, there is no like, it's very easy to just blame that, we cannot innovate because there are all these security protocols we have to follow. Like, there is way too much uh, bureaucracy or anything. Like, we should not treat it like that. It's just part of your job. Like, you have to set up best practices and follow principles, and trust that system, and it needs a company mandate. It does need a company mandate or a CEO mandate, that we should agree that the innovation and security should go hand in hand, um, and and we should not put a blanket over it and say, oh, we cannot deal with it. So that's it.
Yeah. Well, thank you guys for your presentation, and thank you to everybody who tuned in, and we'll see you all shortly.
Thank you.